Good morning, students. Myself Lilufa Khatun. How are you all? I hope you all are doing well. So, in today's class, we will discuss the topic the derivation of Newton's second law of motion in polar coordinate system. See, till that we know about the Cartesian coordinate system, the two-dimensional Cartesian coordinate system. If we want to find the position of a particle at a particular time, say t, so this is the x-axis and this is the y-axis. In Cartesian coordinate system, we want to find the position of particle p, so we can write it as p as the function of x and y at a particular time. And here we want to derive the Newton's second law in polar coordinate system. So what is the advantage of using polar coordinate system over Cartesian coordinate system? See, if this particle p is rotating in circular motion, it is easier to calculate or measure the position of this particle p precisely with the help of polar coordinate system. So now we will derive the Newton's second law. The Newton's second law writes as if is equal to ma. It states, the statement is the force is equals to mass time acceleration. A is the acceleration. A acceleration can be written as r double dot. That means derivative of r, double derivative of r, d2r dt square. So now we will derive d2r dt square as the acceleration, and then we multiply the mass with the acceleration and we will get the force in polar coordinate system. So in doing that, let us draw geometric coordinate system. This is the x coordinate and the unit vector along x-axis is I cap and this is the y-axis. Unit vector along y-axis is j cap. This is the negative x-axis and this is the negative y-axis. Now let us find the position of a particle p over here. This is the distance r. R is the distance between the origin and the particle, and this theta is the angular displacement from the x-axis. Now we can see this is a right angle triangle and this distance is measured by y. So we can write from here this x is equals to r of cos theta and y is equals to r of sin theta. If we square and add this, we will get r is equals to root over of x square plus y square. This is the relation between Cartesian and polar coordinate system. Similarly, we can find theta as tan inverse y by x. Now the r vector we can write from this geometry. R vector we can write that r is equals to x of I cap plus y of j cap. The radial component along x-axis is r of cos theta I cap plus, and along y-axis the radial component is r of sin theta j cap. So if we want to find the unit vector along r, we can write it as r vector divided by the magnitude of r, which r vector is equal to r cos theta I cap plus r sin theta j cap divided by r. So r cancels, we have cos theta I cap plus sin theta j cap as unit vector along r. Now we will find the unit vector theta dot cap along the direction theta. So x component of theta cap is x is equals to minus of sine theta, and y component of theta cap is y is equals to cos theta. How can we write this? See, from this figure, this is the direction of theta cap. This is theta, so, and this is a right angle triangle, so we can write it as this angle pi by 2 minus theta. This is also the theta cap direction, and this is also the theta. So we can get from this geometry that the x component of theta cap is minus sine theta, and the y component of theta is cos theta. Now let us find theta cap. Theta cap we can get as minus of sine theta I cap plus of cos theta j cap. So if we want to find our double dot, we need to do the time derivative of r 2 times. So first we will do the time derivative of r, right? So we can write it as d dt of r vector is, we have seen that r cos theta I cap plus of r sin theta j cap. Here theta and r changes with time. Theta and r changes with time. So we can write d dt of r as r dot cos theta I cap plus r minus of sin theta theta dot I cap plus r dot sin theta plus of r theta dot cos theta j cap. And from here we can get, if we take r dot as common, we can have cos theta I cap plus sin theta j cap here, and from here if we take r theta dot as common, so we get minus of sin theta I cap plus of cos theta j cap. So we can write r dot, this is cos theta I cap plus sin theta j cap is r vector, r cap vector, and this is r theta dot, and this is theta cap. So we get d dt of r as this r dot r cap, this is the radial component, and this indicates how fast is the velocity changes with time in radial direction. And r theta dot theta cap, this is the angular component, which indicates how fast is the velocity changes with time in angular direction. Right? So we have d dt r dot r cap plus r theta dot theta cap. We can write it as d dt of r dot r cap plus d dt of r theta dot theta cap. Let's indicate this as one equation and this indicates the equation 2. 1 and 2. Now we will solve 1 and 2. If we solve r cap this, we can get r double dot r cap plus r dot dr dt. R double dot r cap plus r dot d dt of r cap can be written as cos theta I cap plus sin theta j cap. So from here we can have r dot minus of sin theta theta dot I cap plus of r dot cos theta theta dot j cap. So if we r dot is common, so we can have here theta dot theta cap, and so we have d dt r of r dot r cap is this.